So it should be.
Just 2 more minutes and the bridge will call in. Yeah, that'll connect in just a minute. Yeah, all you'd have to do when it connects is just hit the computer button one more time so it actually comes up on that screen. I'm going to go upstairs real quick and start another class, and I'll be back here to check.
Okay,
Just to
yeah,
make
thank
sure
you
everything's
much.
okay.
Avaya. Please enter your The conference is now starting. You are the first person to arrive. You will now be placed into the conference.
So do you like the file, or you didn't have time to?
Yeah, I actually didn't have time to look at the file itself, but I did take a look in the directory just to see what was present in there. So
Did you look on the image?
yeah. Mhm. Yep.
So if you like, I think it would be really reasonable subject for your in-class
Yeah.
project, and it will be related to your
Thesis.
Thesis. Yes.
Yeah.
We'll go over protocol, but you may place them closer to each other, establish chemical bridge, like if some ligands are peeled off.
Okay.
You may inspect if there are charge transfer states
Mhm.
for participating into conductivity or photo-induced charge separation.
Okay. Yeah, that sounds really interesting too. Yeah, and I remember you speaking a little bit about that yesterday. So.
And if you will find that the system is too large for quick calculations, you can simplify it. I just make sure this one is running, but you can simplify, like right now silicons are passivated by methyl groups, CH3, but you can replace it by hydrogens.
Okay.
It will be so much quicker. For silicon also, right now there are biocompatible DNA bases, but you can replace them by ammonia,
Okay.
NH3.
Yeah.
But if you find it works in a reasonable time, you better focus on characterization rather than building model.
Yeah.
Because time is limited.
Right. Okay. Yeah, that definitely sounds like something I'd be interested in doing. Yeah. Someone spilled some sort of drink on this spot.
No, not good.
Yeah.
There was some wait. Oh, there are newspapers.
Oh, that's perfect. Yeah.
It So please make yourself comfortable and walk into the cluster.
Braden forgot this class started at 5.
What?
Braden forgot this class starts at 5.
What is his opinion about the start of the class?
I don't know. He mixed it up with chemistry seminar. So he thought that chemistry seminar started at 5 and this class started at 5:15. But no, he's heading over.
Good.
So, check your messages, you'll understand. The newspaper.
What's wrong with it?
Lift it up. Be careful though.
No. Okay. So we can count on 4 of you and maybe Alisa, who shows up at 6. Do you know anything about London?
Landon usually works at the Math Emporium till 5, so he might be a couple minutes late.
And 2 target audience people, Christian and Austin?
I got no idea.
So we do have very ambitious plans for today. Ideally, we will cover everything that will be sufficient for you to present when it will be time for presentation. So basically, after today, there should be sufficient skills to run VASP for competitive research. You already know how to plot orbitals, which is important. You do know how to compute spectra, and today we are going to, I promise that we will do anion excitations, and I really want to do molecular dynamics and the movies. If time, the most boring, time-consuming, and not needed stuff is K-points. And if I need to sacrifice material, I will sacrifice it first. And if time allows, we'll go through multiplicity, because you really need it for meta-organic complexes. So, in order to be different, I still owe you a homework that I have delayed. So, in order that we differ from practical example administered last years. It should be something new each year, otherwise it will be boring. So I suggest a nanowire of wet halide perovskite, and you do not need to build it. I will share. Otherwise, we will spend too much time on building. It will be pre-built model, and I recommend you just pull this example from my directory. Later on, so let me encourage, instruct, suggest. Please be very careful with naming directories. I suggest that today you will generate a dozen directories, in each of which you run Wasp with a little bit different parameters. I will give you overview what we will do, and basically for each run, try to specify your unique name. Also, I want to warn you, it is better if all directories are on the same level. If you do list, you can see all of the directories what you do today. Do not insert them inside with the branching. It is also creates complications. So we will do. Before I go to details, it's just overview. For nanowires, we do need K-points that we will neglect for most of time. If you neglect K-points, it is called gamma point in physics community. So for most of our meeting, we will do gamma point. So the name of directory, you may want to like tell my test system _ gamma, and have it all the time, because later we will replace gamma with some distribution of K-points. One thing. Next. We will start with neutral, and then we will practice anions and cations. So you already see gamma neutral, gamma anion, gamma cation. Then we will try lowest excited state. So gamma neutral, gamma anion, gamma cation, gamma excited. And then we will try multiplicity. So hoping that the system is in a singlet, we will make it explicitly. So gamma neutral, gamma anion, gamma cation, gamma excited, gamma spin allowed singlet. And then we will try to change the spin. Gamma neutral, gamma anion, gamma cation, gamma excited, gamma singlet, gamma triplet. At least for an example. So already 6. And then we will likely select the neutral singlet without spin polarization, but we will try to hit and run molecular dynamics, which will be 2 additional. So gamma neutral. You may start taking records so that you build your own system for directories. Gamma neutral, gamma anion, gamma cation, gamma excited, gamma spin enabled singlet, gamma spin enabled triplet, and then we return to gamma but neutral, gamma neutral heating, gamma neutral molecular dynamics. So already 8. And then if time allowed, we will do non-gamma spin distribution. So at least 9 directories need to be created. We will accept molecular dynamics. We will not optimize geometry. We will fix electronic configuration by the keyword NSW equals 0. Make sure that it is present in the in-car. When you will do running for research, you do not need it. It is better if you do optimization, but right now we will die if we re-optimize geometry. We will inherit some error due to this, because change of electronic state results in change of geometry. You know this effects. Stokes, Shift, Frank, Condon, Jan, Taylor, everything is connected. But now we will not re-optimize geometry. We will nail it down, because we have many other things to do. So, I'll go through slides if needed, but I probably just instruct verbally. It will be quicker with old-fashioned Blackboard. I am going to share directory that you copy. There is a constraint. There is a key word. That's what I'm getting. So first hour there will be things that you know, and last hour will be something new that you never saw. If you do not know what to do, just go online for Google and find, if you do not have laptop with you, MobaXterm, and download, install. It will be a shell, like SSH window under Windows that will allow you to connect to a cluster. And then I approach and share username and password and name of the cluster, where we do all practices. We do it on the same facility so that we can easily share files and do everyone stays on the same page. Okay? So it doesn't need any password, just install MobaXterm, simplest version. So I will share, and give me a sign when you need to approach and type in the password or whatever. So in a second I will share the directory from where you just inherit, copy everything. Then you make sure that your in-car doesn't have keyword NLF. Does not, even if it has in mind. Run single point. I'll go through details. And then upon completion, it will be quick. It is a small system. Type grep NLF outcar. So it will tell you number of electrons in the model, in the system. You know from things we do in class that total number of electrons is a kind of parameter for DFT that you can vary, and no one will punish you for changing it if you just mathematically consider this model. Okay? And then we will create new directory where we will modify this number of electrons intentionally. When you modify the number of electrons but keep the number of ions, nuclei, it means you are creating either cations or anions. Since we do not, for the first approach, we do not want to mess with multiplicity, therefore we will change d-cation and d-anion to avoid unpaired spins. But in half an hour, we will deal with multiplicities as well. You saw MobaXterm? Okay, yes?
So without specifying an elect, does it just add 1 and 1 and 1 until the energy goes up and then it goes back?
No. Without specifying, it considers that each atom of each element that you contribute to a system was originally neutral. So number of positive and negative charges is equivalent. If you want to load your head with little arithmetic exercises, you can count electrons just looking at chemical composition. But what if your model is 1,000 atoms of very heterogeneous? You can do it universal. And if you write a code that can parse number of electrons, you can do it universal. Hey, London, how are you?
Pretty good, how are you?
Very, very good.
Sitting all the way back here.
Yeah, someone like spilled stuff in my usual spot.
Too fast?
Yeah.
Is the font large enough? For
Maybe a
you?
little bit bigger.
Okay, we have decided it together last time how to change settings, but
You can just right click the terminal.
wait, what?
You can right click the terminal, then there's an option that lets you increase the font size from there.
Or instruct me up or down?
Up.
Up,
Right
up,
there,
up.
right there, right there.
Down.
Right there.
Yes.
Okay. Excellent.
What's up?
Thank you.
Oh, yeah, I guess you'd have to fix that.
So, please copy content of this directory into new directory for your exercise. Inspect in-car and make sure that if it specifies some of NAVAC, remove it. And then make sure that it has only one NSW equals 0, that it doesn't optimize geometry. Is it large enough?
Yeah.
Good. And then just run. It will be complete in like 30 seconds. Oh. Cancel. Okay, new session.
I mean, it's still actually. I mean. What's that? SCP space dash R, and then space directory name, space wherever you want to copy.
Say that one. Just
So,
SCP space
don't write it down.
dash R space whatever directory you want to copy.
So that whole.
Yeah.
Oh, hey, great. Should I take this organic lab?
It's actually
Don't do it.
Don't do it.
Don't do it.
Content of
Okay.
this
Why?
It's a waste of your time.
Oh, really? It wouldn't help me actually understand class.
No, it's kind of like physics labs. Chemistry labs are the same way. They do labs first and then you learn it later.
Oh,
So,
But even some things in the lab you just never learn, so. I don't
so
know.
I'm making sure that NSW equals 0
If
and
if you
I
want the
put
experience of being in a chemistry lab like that,
that number
then yeah.
of
you have to write up like legit reports.
Oh yeah, every week.
number of electrons is
Much
disabled.
much harder than intro physics labs.
Yeah. Yeah, I guess I'd have to get a rewrite for that anyway. So.
Don't do it. It's a trap. Yeah, what was that all about?
I don't know, like he heard, apparently he was like walking like on the stairs and then he heard my voice and was like, oh, right, he's got his thesis defense right now, so he just walked in.
So unless I'm skipping everything on my neutral directory,
Huh?
I'm skipping everything on my
What
neutral
else
directory.
do it?
So after that, what do I do next?
But just
and then
neutral, no I am
space,
cat lines.
and wherever you want to
Yeah.
copy it to, so just period, basically.
Delete or just put the number, comment it out.
SPE.
SCE.
SCP.
Yeah.
First time you said it didn't.
Uh,
No, for chemical different thing is number of optimizations. You are in your directory, right?
Oh, yeah.
just go like file structure right now?
Yeah.
Space.
Colon,
Oh, cool. Okay.
dash. Yeah, you might want to do SCP space dash car, because then you can just specify the directory name and all. Yeah.
Did you, s-
Yeah, I got a
Be
copy.
recursive.
Yeah.
did you start?
No.
So that just means,
Oh,
yeah.
It's next. I'm watching.
But it is to be quicker. So it is here directly, right?
Yep.
You could just tap.
Yes.
Wait.
This is like an SCP.
Oh, you want to go onto the cluster.
It's the SCP command instead of that. We do the SFTP at the same time.
Why would I want to go? Because we're running stuff.
You need to use that.
Yeah.
We're right, but aren't I? Oh, I'm copying that to my directory.
Your-
Like on the
your-
cluster.
Your
Yeah,
M
you should be.
Why would I
476.
SCP it then? I can just copy it.
Oh, I always use SCP.
Yeah, I never use SCP when I'm already in the
Well, right,
system.
yeah, it's pointless because that's the whole thing.
But-
It's
but you
SCP is
could,
supposed to be like
so
across
I'm
hosts.
doing
Like-
Yeah. No, I always use SCP. That way I only have to remember one thing.
Electronic equivalence.
Copy is just as good.
But SFTP.
Yeah. I
I'm
mean,
just curious what this means, if this is
I don't know.
anything
Don't
yeah, I
worry.
mean, CB is probably better.
in general, just don't
In-
worry.
in,
Well, I mean, if you're already like there.
Yeah.
Wasp is very forgiving. Can you?
Recipe something that would be interesting when you compare.
Yeah. If there's like internet
Yeah.
traffic. Yeah.
Right.
No.
Yeah, I mean, it's still.
Is
works
it job
anyway,
complete?
but-
Does SCP even work with you?
Here.
I've never tried it, I guess.
Yeah.
Like,
That's all I never use CP or SDFP. I always use SCP and it works
Okay.
fine. So,
Mm,
like even if I'm on the
When you make
same.
a copy of a file when you're using
Рассказать надо.
like if you
Where?
want to make a copy of a file
Yeah,
with a command, you're gonna use
you can still use SCP. So you can do SCP like
Inside
file. Yeah.
directory.
Yeah.
Everything. What?
I can do it.
Yeah.
Huh? You alright?
Okay.
I'm just like constantly, like typing, like
just
use
want
stat or
one.
ls or cos.
I can check.
Oh.
So, are you done? Are you done running?
I'm done.
Okay, what we much quicker.
No.
Yes.
Backspace, everything. Like, delete your line. Go to in-car. Because you have to change a couple things before you actually run. It takes like 2 seconds, dude.
That's 2 seconds too long.
Okay, did you comment out NLI?
How would I do that?
It's commented out. What are you talking about?
Well, I can do that.
Okay, exit out the file. And then just run fast.
That was weird.
Dude, I use VI.
VI is life.
Yeah,
VI.
Yeah.
best text editor.
It's the
No,
best.
it's pretty garbage.
What?
VI?
Do you use Nano or
There
what?
is no reason for VI.
do you-
Unless you're like some alien being that
Dude.
wants to be confused.
I mean, the only reason to use VI is because everything will have it.
Dan, what do you use?
Nano? Emacs?
No.
Oh, gross.
Oh,
Emacs is slick.
dude.
I got ruined from Bong. Never again.
What's wrong with Emacs?
I want to do like Emacs hotkeys when I'm in other things, and it's just like crap. I'm not Emacs. I can't do it.
Dude, you wanna know what the best text editor is?
What?
Genie.
Oh, Genie?
I've never
Yeah.
used it.
It's like super nice because you can actually like copy and why is my thesis still open on there? Oh, I guess it keeps all your files open unless you close them.
Interesting. What do you think?
That doesn't sound good.
It's really short.
Mine took longer than that.
Mine took about 10 seconds. I'm onto the cation and anions already.
Is the resulting calculation a wave car?
It creates a wave
Creates
car,
a wave car and
but you don't need it. You don't need it for the future calculations.
okay, I just want to know if that's what
Yeah.
comes out.
To know if it's finished, though, you can look in your outcar file, and at the very bottom, it'll say like writing wave functions or something.
Yeah.
Maybe. I got core stuff. Oh wait, no, I was already there.
If you see files that start with the word core, just erase all of them.
Seven, nine, five, six. I guess I'm not. I haven't watched. There's got to be a way to scroll through. Watch that though.
It's already done.
Wait.
I do this error or not.
Yeah, I'm working on cation and anion right
So
now. Yeah, I finished that one.
Okay. Works. Do you work for you?
Yeah.
Okay. So, which numbers did you get for number of electrons?
208.
Other opinions?
609.
Okay. Right now we are doing it for like education. When you do it for research and for like profession, you should be very careful. But now whatever you got, if you got odd number, just add and subtract 1, because it is much easier to live with even numbers. If you already got even number, add it and subtract 2. But please create 2 more directories. One for anion, another for cation, and in each of which, please explicitly add the keyword nelect or whatever you just copy paste from what you see here. Grep. So nelect. Just copy this number. To keep the syntaxes, if you miss or add a letter, it will not recognize. When you do grep, it doesn't matter. When you put it into the in-car, it should be literal. N-E-L-E-C-T, number of electrons. And then in the anions and cations, increase the number. So, I promise I will give a homework. And there I will ask to plot density of states for neutral anions and cations. If you are ahead of the class, please, you can do it right now. and see how density of states for anions and cations look like. So let me do it in front of you so that we are on the same page. Not density of states, but anions and cations. So I am making directory for anion 1 because I already tried anion. And I'm just copying everything to save time. In fact, I need only postcar, podcar, key points, in-car. But if you are well organized and not lazy, you can just subsequently copy these 4 files. If it is too hard, just copy everything. It creates additional garbage on the cluster, but it will save your time. Then you go into this directory. So and modify. Always, if you do not know what to do, copy contcar into postcar. If the geometry was not changed, it will not hurt. If the geometry was changed, you will keep consistency. So vi in car. So I keep NSW equals 0, and elect if I want to do the anion, I will do more electrons. And then I save and run. GOB. So it's already running. So today is a lucky day for the cluster, or for us. There is no waiting in the queue. And you do see how the electronic iterations develop. Because it is a small system, it updates in real time, and you will see that if it will come to number 60, it will stop, and sometimes you reach convergence quicker, so it's maybe a minute. So while it is running, I am returning to
basically, it's like, you know where all of our music vectors are? Or where did you get that neutral from? Like the neutral vector? And then CS search stuff, and that'll be anion.
I'm trying to do homework ahead of time. Number of atoms. 9 plus 4, 13. Plus 16 will be 30.
Yeah. Just the words run fast is one more. That's it. Yeah. You make it whatever your thing was plus, and then round. Yeah. Yeah. So 210.
So please do it for both cation and anion. And what I'm doing is just pasting the density of states. So right now, right or wrong, but it looks like there is a band gap. Valence band is occupied with red, and conduction band is empty. And when you practice creation of cation and anion, you may want to do the same picture and observe that for anion there should be red stuff in here, and for cation there should be no red stuff in there. In addition, the absolute values of energies will be shifted. So if you would live in the electron where in the universe where electrons do not interact, it will be just repopulating orbitals. But since electrons interact, there will be also change of the orbitals.
It doesn't matter. You don't just like.
Yeah. It'll.
If
Yeah.
you watch QStat, it'll just do it in real time. So if I'm going into the directory with
9. And even before I start to plot density of states, so here is an, well, it is trivial effect, but you should get familiar with it. So before our HOMO was 104, right? Or if you have doublet, you'll see a little different. But right now, and here's the gap, about around 12 volts. Now you have occupation in 105 because it is anion, more electrons, right? And if you do density of states, it will be reflected in the image. So based on the list of orbitals, you can build density of states image, right? So you launch this DOS script to generate the data, and then this GNU plot script, you generate the PostScript file, DOS PDF, and then you are able to plot the density of states and see that above the gap, the orbital that was lowest unoccupied, now it gets occupation, right? So please, if you are ahead of the class, try to do it. I will gently ask you to do it anyway for the homework. Okay, so please give me some signs if you need more instruction on this stuff. if you were not able to get anions and cations. Okay.
I still remember how to like get the plot.
Same as
I don't
video.
remember how to do it beforehand either.
And Vijay doesn't want to show his skills, or is
I was
just
just showing him
instructions?
my plot, but I can show him.
Just, I just
Okay.
remember like the command. Like,
Okay, but
or like which file I'm trying to pull
Can you
stuff
just
out.
do it up there again? Because I lost track where you were a long time ago. For the.
oh, okay. So you all would appreciate homework as a skill of plotting DOS with VASP is a minimal necessity to pass the course. We cannot get without it.
Right. I just there's way too many files for me to remember what exactly.
Sure. I demand from you guys much more than I was able to do myself. It took me 3 years to figure it out.
So like, what does the N flag do?
Number? What do you mean?
So then the 300 just wouldn't mean anything without that flag.
So I'm just parsing the part of the output that lists groups. Just copy paste, which is tail end of the file, parse. Minus n means like 300 it's from the bottom of the thing.
Okay. So like the 300 just wouldn't mean anything without the N flag is what is happening.
Exactly.
Okay.
And now
So like what is WC?
water closet.
Word count.
Yeah. Oh man.
So 16 plus 4 plus 9, 29.
Oh, okay. Yeah.
Okay. What is
Guess that's
06? Okay. Now we do take long before we will miss binary slash plus. Okay. And then it starts asking silly questions. States minimum, maximum, something.
Okay, wait. Hold on. Where did the 107?
WC states 107.
I still, I guess no.
Are we working with different molecules?
How many
724.
lines
Yeah.
is contained in the file states?
So.
Okay.
Okay, so basically like.
So, okay, so the state's just
Basically,
this.
like, the
So that's,
procedure
okay.
that I followed was, so I went to my output file, some
And then this is
states,
just kind of arbitrary based on like.
and then made a new file.
No.
Capital states,
Or like,
pasted them there.
is that
Good.
So here you can see like different energies, like the number of
When
states,
it's
the
trading,
number
so
of
when you
electrons
get
state.
into the home.
So after you're done with that, I just did grep Fermi outcard, and that'll give you like the Fermi energy and alpha plus beta, which you need for input. And then you go to, and then you just run the script. You just run the
Well,
script.
when I was typing, it was recorded.
Dress,
yeah.
And I can try to.
norm.
So like, what is that alpha plus
And
beta
then
value?
After that, you just
You don't
type
care.
in like everything, so
Well,
like the number of
what's
states
that?
that you want to
Yes, you
plot,
do. Number of states.
the minimum energy that you want to
Minimum
plot,
energy, maximum energy.
the maximum energy that you want to plot, the Fermi energy, alpha plus beta, and then just different parameters. Like I want each line in my density of
So the
states to
Fermi
be,
energy just determining where your zero is on
I
the
want
plot?
each
Okay.
There is a way to.
yeah.
There is a way to. there is a way to plot density of states centered where zero is placed at Fermi energy. We are not doing it right now because to see the chemical implications. If you do anion, it has occupied above with positive energy means it's like unstable. You can water center. But there is a little change in the scripts that will center density of states with zero will be always at Fermi energy.
Okay.
We are not debating this.
This class is not correct.
Fermi energy is around like maybe 1
Maybe.
Okay, so then the
So
line
you're talking about,
is
you're talking about this thing?
well, right, but that's, you're not
Fermi
pulling
energy is
for
always in the
anything, it's
middle
kind of
of
like
the
I
range.
want this
Yeah.
number.
Yeah.
Okay.
Number of atoms, 99, number of protons, less than
Way
that.
too.
Yep.
Yeah. Well, because right here it also says like negative 1.4. Yeah.
Fermi energy is around
Right.
that.
Right.
Yes.
Yeah. Cool.
Yeah,
What do you
I
know
guess
if
like
the
I
gap
was-
will fit?
I thought we had to use this number here. That's what I've been using.
Those numbers are for normalization.
Okay.
Well, right, yeah,
It
'cause the
will
band
may
gap's
change your
negative.
y, but for density of
Yeah.
states it's on the position of x.
Okay.
Crap.
Okay. So it's created this.
He goes from negative 10 to 4.
Now do-
Right.
Like he takes way too many states.
Yeah. No, yeah, that's definitely more than 20.
Okay.
Okay.
Yeah, so I'm just using 0.0. Yeah. And then basically number
Okay, so the
atoms.
first script that
number
you
of
ran did the
electrons.
DOS Fermi norm?
And
Or the
this
DOS
is base,
Fermi,
yeah.
DOS Fermi norm?
Yes, just for the norm. And then the
So
second
that
step
writes like a
uses
file.
that file to make
And then
DOS
you just
specials.
run
Okay.
GNU plot, and then go back into the bit
Yes.
folder, and there's a script called nukepro
What's the RGB
underscore
thing?
DOS.
Right.
And then that'll generate a PS file, or a PostScript
Read.
file.
Right.
And then after that, you just
Right.
convert it to
It's not neat,
PDF.
it's not neat, it's with the standard.
PS to PDF,
Convert.
WR,
Well, I've used like PS, PDF, but I've never
PostScript
used the
name,
WR at the end of it, I guess.
Doesn't matter.
and then
Whatever
you have a
works.
PDF file that you can copy to your computer and view.
Those digits.
Yeah.
I want to see what.
So if you.
Okay, yeah, I have a couple of them on here actually, because I did that for the cation and the anion cases already. Yeah. So I don't have, I guess, many states.
Whoa, you want to went
Oh,
from
classes.
Right.
Oh,
Yeah.
Kind of just, yeah.
Yeah, so
see
the
what-
cation case, you can see this
Oh,
one's
it's
empty. I probably should have done more here. But, yeah.
Not bad stuff.
Yeah. Your brain hurts.
Yeah.
Huh?
I can't like.
Imagine giving an hour-long
Private terminal
presentation.
right now.
We're-
Yeah.
So, first part,
Hmm.
I'm sorry, the last step.
Okay, you mean like copying like states over?
Yeah, how did you make that
You
states
gotta-
file?
You just basically take stuff from your outcar file where it writes like the number of electrons, the energy, and like the state number. You copy that, and then you open a new file called states, and you just paste it in
Or you
there.
just copy and paste it into a file. There's
Yeah.
no script that does that for you.
No, not as far as I know, at least.
This, which
Should be done.
but bring it up to.
Yeah.
Okay, so see, if someone didn't got cations, a nice Cartesian density of states is shown on the screen of London.
So the environment management is deficiency of calculation. Right.
So it is a good image to follow.
Let's see the line it actually represented the stuff.
Right.
So, where did you go to?
Oh, just
Out car.
So you typed in VI out car.
Yeah.
It's the thing.
And you just copied it.
So
Not all of them, but yeah.
If you did all of them, then you would have a better picture.
Right, yeah.
I was trying to.
So then so you like copy all like whatever number you grab.
Yeah.
And then you take those out.
Yeah, and then states, yeah, and then you just copy them in.
So you just created a file states.
Yeah.
So if you just type in VI states, it'll just pop the thing you just paste in.
Mm-hmm.
Okay. And then after that you repeat all cars.
Hey, Landon, they have Emacs on there. Cluster.
They do?
It just, yeah. That doesn't. Gross. How did you get that many states? Oh,
So did you select 200 and some?
What?
Did you select all 200 states?
it's only like 20 lines.
100. So.
How did you do it?
Yeah.
Copied?
I mean, they're trying to get more states in there, so.
Just open it.
Oh, you're
Yeah,
wondering like how?
we get.
Okay,
The
so
opening
he made
is- oh,
he made a file
oh,
state
okay.
and
Yeah,
copied that.
no, I got it.
Yeah, so I need to copy these first and then just type in VI states.
Yeah.
Paste that into that.
He did.
Um,
Are you at the end of the file right there?
Oh, there you go.
Close to it. Go down.
No, it should be further down.
Okay, so
I
right
don't
away you
actually
copied
know.
like 300 lines.
Oh, there we go.
And then
Yeah.
like right just to get like that chunk, he did like the first 300 lines.
Skipping. Okay,
That's
that's
the last
helpful.
300 lines.
Eh. I don't know.
Oh, you don't have to be able to look through all the commands anymore. It's gonna be all fucked up.
You should be the master of this room. How you gotta make it on your own.
All right.
Password doesn't show how many characters you type in.
Oh. Yeah.
No, you created a password. Oh, no.
Oh,
Directory.
yeah. Let's see if we can do this. So, oh yeah, I already read. But he made the cat sometime for me. I mean, huh? Oh, shit. Which car? That's the one. That's the one.
Lisa, how are you? We all are so good.
That's how you do it?
Oh, that's This is gonna grab the last 300 lines now. That file that I just made. Okay.
So I type that.
Oh.
Didn't quite get all. And then I need to chop off the bad stuff.
Should just delete all of them.
Or maybe you can just delete them.
That's the end.
Right. Okay, so I needed another.
No way.
25.
Yeah, I don't know what that is. I was really
Next. That's too many.
Just one big, not next.
Who's the script that you ran? Dress dogs.
Are you the one
Yeah,
just
dress dogs.
DOS_norm.
Yeah.
Arrive on Wednesday night,
Yeah.
so on Thursday you'll be ready to listen to the next presentation.
I don't think that's good.
Say thank you to Russell. He was first. You can go see something. Do you want me to?
I don't remember.
Okay, I'll approach him.
Okay. So. Okay, so that's. Yeah. So you think I forgot the last file. The end will tell that you're going to tell it how many numbers or like how many lines to copy. And then 300
I
steps.
didn't get too far because
So like.
because
Yeah,
I
going to copy
he was lazy.
300.
That is definitely okay.
It's just cuts.
I don't think there's a that.
Right now.
Just a minute.
So we're at 4%, so it's like.
Yes, but it was not distributed. Yeah.
Well, that's kind of what I
One
wanted
hour
to
is
say.
passed, but we are done maybe 15%.
Yeah.
That's what we did, though. We just did
Wait, how'd you copy all of the lines? Like instead of just.
Oh, here, I'll show you.
The tail native.
So like, yeah, I just like output, I redirected the output and I
Okay.
input in there,
Oh, dress dogs no is
asking a bunch of questions.
no, it's an executable.
Yeah.
Yeah.
It's not a script.
Oh, wait.
The dress dogs norm.f is a Fortran code
Oh.
that is being run, and all you're doing is you're executing.
Alrighty then.
So I tried to open dress dogs norm, it didn't work out very well.
I like that.
Crap.
Yes, yes. Tail means end of file. Should and not from all cards. Then I manually edit the keyboard. We didn't do and this. Doesn't matter.
Oh, that's.
Oh, God.
Script you ran after the dress dogs norm.
It's in bin. It's newpro.dos.
What's the file path to get to the binary constant we want?
~bin/ and then file name.
But I'll show the.
Oh, so it's just literally right
Yeah.
there. Okay.
So,
Uh, No.
no, well, I would say.
That's it.
Yeah.
Dress.
This is absolutely necessary.
Okay, number of states, so we figured that out. So that was 128. Yep.
Did
Oh,
you
shit,
have
shit,
it?
shit,
You
shit.
had it working.
Yeah, so we need an energy. Certain
But you forgot.
Right, no, I'm just trying to, because this is like, this is why you do all that stuff, so we need this. So we need an energy, max energy.
Yeah.
Yeah.
So you can stop.
Right.
More.
If you do not
Escape route.
Yeah, limit to heart rate level.
That's literally what we're looking for. I don't want to.
He's always.
I don't want to repeat things. It's like it's choppy. Okay, so.
So now you do stress.
I don't remember. It's product. There.
Wait, it doesn't matter what your max and min. That's
It
just.
does, yes.
Well,
So.
if you go over it, it
So, okay, so here's our minute down to negative 3. So we want to go from negative 1, say, to 3.
makes sense.
So. Wait, there's a.
Now, draw set.
That's not that. Oh, there we go. Look at that.
It's in the outcar file, so
Yeah.
grep Faraday out of your outcar. And that'll get you your alpha 1 beta as well.
Hey, Landon.
Oh, I love that already.
Oh,
Yeah, I know.
damn.
Oh,
You put that boy in a physics Playboy.
Right?
Plus, just still those new plot scripts.
Please, please. No, use of duplex scripts is allowed only on HPC, USD HPC.
Oh, shit.
If you pay for
What's a good thing to put for the magnitude?
1.
1? Okay. Is there
Oh,
a
fine.
rhyme or reason for that?
Huh?
Is there a rhyme or reason to that? I mean, what's that determined?
So right now, there is no reason for anything. But when you do research and you want to compare density of states of heterogeneous systems with different number of atoms, like quantum dot made of 30 atoms or 300 atoms. Because of number of atoms is bigger, number of electrons is bigger, and this will push up, right? And by human eye, it will be hard to compare. The length will be by like 10 or larger number of. But in this, there is a normalization. It divides by number of atoms, number of electrons, and then lines will be almost repeating each other. The difference will be only because of confinement. So right now there is no reason, but later there will be benefits.
So magnitude is
Factor, scaling factor.
Okay.
If you do not like, if you want it to be twice bigger, you just put 2.
I thought that was a different thing that determined that.
No, it's not different.
Oh shit.
Please give me signs if you are not comfortable in plotting these images.
What?
You can do it, right?
I missed what you said.
Just confirm that you can do such images.
I'm trying to do it on my own right now.
Do you hope to be successful?
So far, we're on the right track.
Right.
Okay, good. It is what I want.
He put oh, so we no, that's
Wait,
not
are you talking about a number?
Yeah.
Who will-
Yeah, it's 29.
It's 29.
Yeah, 16 plus 4 plus
Who will be
9.
presenting anions and cations? Okay, and you do not have problems.
So you would get that from
Okay.
your in-car.
Which is, it's just you and I.
No, that's not.
It's just you and
Figure it out, I tell you. Yeah, that'd be good. Yeah.
Be careful, we are on the record. It is technically possible to remove something from record, but it's a lot of time to find it. And
Beep certain words. Like
probably, but
censor them.
I do not have this facility. And if I download it on local computer, it starts fan on, and it takes a long time to process. So it's much easier to have it plain.
Which one did you screw up?
Oh, because states actually needs to be in a very specific format for this to work.
So,
Can you come show me how to modify the states file again?
What's going on over
Sure.
there?
So, okay, so I did like, this is what I did. I just basically went like, okay, let's just take like those lines from our car and dump them into states. But then like, how do you actually select?
Well, something was wrong.
Oh, whoops, it should be tail. So like I just did that, and then how do I?
Okay.
Because you did the same thing, right? You just like shrunk it.
VI.
And I didn't.
I don't remember you going into VI when you showed me. So I thought you did it all from command line.
No, command line VI. So, and I do not like what is here. I just
Right.
like do it.
I swear to God, you just did it like all from command line.
I guess there's a way that I tried to do it. Like if you do head space dash n,
And then I do it. Yes, yes.
Yeah.
It's the right way. And
sorry,
I used to write a script for me, but too many scripts get exhausted.
Yeah. Yeah, no, I just used head and like
No,
put
you
like
don't need
a certain
to
number of
after
lines
you
into
say
another
something.
file that overwrites states.
How do you not remember this?
Or you can type D 1,000 times D.
That works.
Right?
Right. Yeah.
Now,
Okay. So then from there, I should be able to do it.
Okay, that was the only thing wrong.
Yeah. Oh wait.
Wait, what's the WC?
Oh yeah.
Oh,
Yeah.
Water closet.
how did you make a state file?
so let me assume that you all know or are very close to practically know how to make anions and cations, right?
Yes, that was it.
Now, I'm going to new material because time is running out. So I'm erasing it, right? You do not need this little instruction.
I'll just take a picture.
Please. And torture or question Daniel. He should be able to instruct you on doing it. Okay? So, kind of done with anions and cations. I'm going to tell something and explain something. There will be a very big challenge in what I'm telling. So, it's not, how to say, humble to say the following, but you will not regret if you listen to me right now. Let me attract your attention. So, a lot of materials are being excited by light. There are very advanced and complicated theories to describe excited states in all its complication. We are going to assign specific chapter last 3 or 4 weeks of the class about it. Right now, I'm going to show a cheesy way, well, respected cheesy way, simplified approximation to describe excited states. This is beyond any criticism. You cannot go in public and tell, here is my excited state, but it is a thing that does work. Okay, so when you look on the states file, you observe that your orbitals, 1, 2, 3, then whatever, 100, 101, they are 2, 2, and then 0, 0, 0, right? Which means your lowest orbitals are all occupied, next orbitals are unoccupied. In very simplified way, what excitation does? Simplified, oversimplified excitation. Forget electron hole attraction, forget any correlations. You just promote an electron
To a higher state.
From occupied to unoccupied orbital. Okay? Do not tell it in public or do it with a not very loud voice.
I was gonna say.
Be careful. Wait until end of the course. We will go through right terminology, how to at least speak about excited states. But inside us, it's fine. Same as electron rotating around itself. For spin, excited state is just promoting electron from occupied to unoccupied. Simplest excitation is promoting from HOMO to LUMO. So if we would practice this philosophy, then upon photo excitation, the file for the file states that you have for your density of states should be modified in the following way: 0 here to here. And I'm putting zeros instead of 1 because I do not want to mess with multiplicity. We have a specific chapter on multiplicity in whatever 10, or if you are very slow, in 40 minutes. Okay? If you can make states in this way, it will be excited state. Can we just modify, just cheat and swap the numbers? We can, if electrons do not interact. We can, if electrons do not interact with ions. But it is not right. We cannot sacrifice all effects. So we need to establish population of orbitals manually in the INCAR file, and then run VASP job with these constraints. So in order to set up explicit occupations of orbitals, there is specific command. Because occupation of orbitals with electrons generally is referred to as Fermi distribution. You've heard of it. So, and those are weights. Weight or number, occupation numbers. The key word for VASP is Fermi weight. W-E. Fermi. Okay? Now, suppose that you have a total number of orbitals 128, right? Suppose we are talking about how many orbitals are occupied. Occupied 104, right? So, first, I am going to do nonsense. Do not follow me in calculations, just by your minds. First I will do nonsense, then I will do sense. So if I want to do identical operation, I want to practice Fermi command that will keep ground state. So nominal practice of Fermi operation that will not change actual occupation. I just want to reproduce ground state. So I need to write Fermi equals, and then I need to write 1 space, 1 space, 1 space, 104 times. 104. Then I type 0. Oh, not 4. Yes, but. And then I type 0, 0. How many times? 128 minus 104 equals 24. So for 24 times, I type 0, 0, 0. So if I add the line Fermi equals this line in the INCAR file and run VASP, I will get the same result as if I would not have this command. It will reproduce the ground state configuration. Okay? If you are making screenshots, do it. Sorry for being not humble. Not me, just image.
Oh yeah, I
Good,
did.
thank you.
Here's the computer.
Now, if you want to model the minimalistic excited state, we need to replace this last one by 0 and replace this first 0 by 1. So invert. And if you do this and run VASP, you will get approximate description of excited state. What is very important for chemists, or for those who want to study chemistry even not being chemists. If we do MSW equals 0, it will be big approximation. It is like frozen ions. But if you believe that positions of nuclei do not respond to electronic configuration, you are fine. Which is good for very rigid solids like quartz, silicon dioxide. It doesn't feel whatever you do. But if it is a soft molecule that experiences like dye, that experiences Frank-Condon effect, that experiences Stokes shift, photoexcitation leads to rearrangement of position of ions. Therefore, you need to put at least some number here to allow ions to relax a little bit. So I invite you to create new directory where you repeat like name of your compound, gamma point. You can tell that it is neutral, but then underscore excited or underscore Fermi weight. And then add this sane into the incar. Some of you are promised inside yourself to kill me the next second because you are lazy to type 100 times. You do not need to do it. I was thinking about it. So instead of, by the way, now you need once for 103 times. So you can type 103 times 1 space 0 space 1 . Focus, focus, focus. Focus more, focus more. Good. Space. Now we need 24 minus 1. 23 times 0. So Fermi weight, Fermi, equals this stuff. I will distribute a piece of paper that reproduces this thing. And you can set up you can find an equation. If you had like x occupied and y unoccupied, you have x minus 1 occupied here and y minus 1 unoccupied, and here the inversion, right? Because from system to system you have different numbers of occupied electrons, and you want to be u to be inversion.
So I'm just.
Thank you. So what is NSW like? What is that parameter?
It is number of ionic steps. How many times you update positions of your ions.
Okay.
I'm going to do this to do the same, but you are welcome to. If you have an idea what to do, you do quicker than I do, because you have a brighter brains and quicker fingers. Just a second. I will just want to focus camera in the optimal way.
So is this Fermi weight in the part?
Yes, yes. And if you look for binary tilde slash bin slash incar, there will be about a couple of dozen templates for incars. And you will see incar Fermi or incar excited for for this, how to say, formula.
Yes?
Well, my question is about that. So if I set that to some ridiculous number like 10,000, would it go until it hits a different command, the minimum criteria for energy difference between ionic steps, instead of that?
If you put 1,000, it will stop upon reaching convergence.
Convergence criteria.
Yes. We are not practicing 1,000 times, or if you're just not writing it, not specifying it will go into convergence. But there is no guarantee that optimization will be quicker than the time of assigned for the class.
So should we excite the neutral?
Yes. Well, for practice you can do anything you like, but it is reasonable to start with the same origin in the space of different configurations and just depart from there. Because if you do simultaneously change of number of electrons, excitation, heating, and molecular dynamics, you go too far. Hard to analyze. And if you are super quick and you do not know what to do, you are invited to make density of states for excited state and see how does it compare with neutral or cation or anion.
So when we do this, we still want to have NLEC commented out? Or do we want to have that actually as part of the in-cars?
If it is neutral, you can have commented it out.
Okay.
Just try several times, and if it works without error, it means you are right.
Shift I. Shift. Yeah, and then that will allow you to enter. Press enter.
Shift.
Press. Yeah. I don't know if you need shift.
You don't need shift.
Always. Okay.
Because that's just usually. Right.
So we don't need to change NSW? We're treating it as a...
It is just put some nominal non-zero NSW, like 5 or 10, just to allow it to relax a little bit. When you will do similar things for research projects here in class, you will just make it 1,000 or whatever it needs to.
Will it crash if you screw up the
Yes.
like the 103 and
Yes.
23?
Yes.
Okay.
in this top example here, is there a missing 1? 24 times 1, 0.
Oh, this example was 7 years ago for very different system. Do not, please do not literally copy numbers.
No, but oh, okay. And ice mirror should be negative too.
Yes. I wasn't instructing it explicitly here, but if you are not using template, but you are modifying in car yourself, put ice mirror equals -2. It means it tells to VASP, I am going to manually set up the occupation of each orbital. If you put it ice, okay. If you do not set it up, it will read it according to Fermi distribution anyway.
But if it's -2, it looks for fair way.
Yes, exactly.
Does the order matter?
Huh?
You do fairway and then ice mirror?
Yes. At least I was doing it and I wasn't punished. But
Okay.
The order matters.
huh?
The order matters.
Wait. Order doesn't matter.
Oh, okay, yeah, cool, that's what I was just saying, is that I just threw it on the end and it worked. Thank you.
If you repeat the same keyword several times, the last one does matter. If you like write number of electrons equals 1, number of electrons equal 2, the code will think that number of electrons equal 2. If you swap it, number of electrons equal 2, number of electrons equal 1, the code will think that you have only 1 electron.
So,
Just a second.
I got that too.
wait, did you make it that street space?
Yeah.
So, rating?
I'm rerunning mine because I forgot to do ice cream this thing too. Because it's basically like telling you to specify your own electron density.
Something about smearing.
Sure.
So what does Wasp mean? So Wasp give you different fine energies.
Ice mirror simulates temperature and it's at 0K for the electron
So what does
occupation.
What does it do?
It's kind of a
Just use standard DFT
it's just a
procedure.
cheating method to see the occupations at like room temperature or something.
Therefore,
Even though you did
You just give it a number, don't you?
no. You can see and derive.
Like, don't you just give it like 28 or something? Like, just a number?
Ice mirror?
Yeah,
If
sure.
you said ice mirror
No,
equals
it's not
0,
the
then
same
just do basic,
equation.
probably room
Because
temperature,
solving the Cauchy equation for
Fermi-Dirac distribution.
occupied and unoccupied orbitals. What's
So you'll see a little bit of stuff in the LUMA when you wouldn't think there would be at 0K. Which is true, there shouldn't be, but it's kind of like faking it. And here now you're just specifying specifically the occupation.
For ground state, you have like orbital number 1 squared plus orbital number 2 squared. For excited, I'm oversimplifying. Orbital number 1 squared plus orbital number 3 squared. Since orbital side 2 and 3 are different, density will be different and external potential will be different.
so now it treats the ground state as 2222202,
Yes.
and that has different density. Okay, but that's not it.
It is not, but it does work. It gives, we cannot prove, and it is quantitative is very good correspondence with experiment.
Oh.
You can prove it as a theorem and get famous.
How do you run commands on repeat
Okay.
in VI?
Let's get
Like
on
how do
that.
you run like the delete line 1,000 times?
D? Just D? 1,000?
Yeah, you literally have to just type DD 1,000 times.
No.
No? Oh.
Okay.
Okay, so you just type
Oh,
the number and that'll do it. Okay.
Uh-huh.
Oh, okay. Wait, what was
You
it?
have two letters
You
there,
just
let him
and
know
you can
that.
insert another
Literally just like
between
type the number of like times you want the command to repeat itself.
Oh, okay. That's handy.
them. Oh, you do?
I'm so, I just got up.
There's always colon Q exclamation point if you screw up.
Yeah, right.
True. It's not like in the actual command line where you just screw up and you're that's screwed.
Okay. So
Need
to get in
Okay. Last time I was showing it to Daniel, and you were also was learning to Daniel. Now I will show to you, and you will try.
I've worked here that long, but yeah, a little scared.
Remember the silly person.
Do they lock the door between Lad and Dunbar?
So,
But I know the doors connecting to Skyway.
Yeah, some of the doors in this building have electronic.
Yeah, the doors to this building, yeah, but between Lad and Dunbar, like the ground level.
Oh, no.
Oh, that Dunbar.
Once
Okay.
you get in, you.
So, yeah, if you ever need in, I can get you into Lad.
No.
If you need.
See,
when I
parent doesn't want me to have a key to go in, so.
Why?
Because he doesn't want me to go in there and just randomly check on the lab, even though I'm gonna do that today, because there's a roadmap going on right now. Synthesis takes.
How are you gonna get into the lab if you don't have a key?
Huh?
Don't they lock the lab doors?
Go in there, finishing up my reaction, but the rotovap's still going, they just left the lab unlocked, so I
Oh.
wanna go in there and check on it and then lock the lab.
wait will be 10.
Check.
Just in case.
You never said we follow all of the rules.
Just in case.
yeah.
What is it?
That's pretty
Do you need to depart?
Yeah, I gotta go check on a reaction. I do.
What do you present?
The orbitals.
Oh, okay, so you're safe.
Yeah.
No, we just need.
Adios.
See ya.
I don't know why I started being like right.
What's up?
Started being like right. Wait, check this out.
This is one. Cosmetic. This one is.
How many atoms
So this
29.
these numbers altogether 123.
What's this?
Plus this is
I set it equal to -2. I'm not exactly sure like,
120.
why that choice is
Yeah.
right.
1, 2, 3 plus 1.
Now I got.
No. No, no, no. Yeah, like one zero, sorry. 1 0, sorry. Then we make a
I just put in a random number for them.
Okay.
I've noticed that it doesn't matter.
No.
What material are we doing? Are we working on
I would keep
CS?
occupied.
It's a wire.
But I'm flipping.
Probably like 2 EV.
How do you like this type?
It's 0 to lower each day.
It's nice. Sure, because those with the time. It's a nice choice.
Yeah, just.
Okay. I was like, it's beige. I thought it was like.
Oh, never mind. Yeah, I was just waiting.
Like where I was at, the way it was reflecting. Landon, did you get it going?
I got it going. I'm trying to plot it right now. I just can't remember like what I need for the plot.
You need this page.
I'm gonna try to do it, and then when I get stuck, okay, I gotta find that thing.
That probably would have been a good idea, actually.
Everyone was able to run okay.
Is it wrong?
Braden seemed to achieve success quicker than myself. So take him as a good example if you doubt how the results should look like. So just visit him as a museum and watch the figure that Braden is showing seems correct to me. Okay? I don't know why maybe he's luckier than me. My job is still running. His is done.
I have a question.
Yes, please.
So we
Oh, just a second. If you anticipate that job will run too quick, you can keep NSW equals 0 or maybe 1, because most of time, well, you know the truth, but you know that this truth is expensive. And for learning purposes, we can skip this optimization, because look at me, it takes time. Your question?
So when you excite two different electrons, like having two excitons, right? So bi-exciton generation.
If you tell that by this you excite two. If Braden will tell that he will excite two electrons by this Fermi command, DM will kill you at once. He's already
No.
But I mean,
just because he's gentle.
but that's what we did, right?
Well, even creating one excitation by this oversimplified way is a big insult to a field theory theorist. It's a true excited state is more complicated, as you may know. And if you do more than one excitations, it is the error will be even bigger. So you may try it, but you should be very careful and realize that like you want error be smaller than the value of observable. But if you go too far in this direction, value of error can be bigger than the value of observable.
But what if we chose one instead of two? Then you have to specify the multiplicity.
If you select one instead of two, it will be even worse.
Why?
You need because of multiplicity.
But if you specify it, then
the keywords will be different. Excitations with explicit multiplicity use different keywords. In addition to fer v, which will specify spin alpha, you have a fer do, which specifies occupations for spin beta. I do not know who is do.
Down.
Down. Oh, okay. Okay, fer v, fer do. Fer down. Fermi down.
so the only thing this gets us is the DOS.
You can get spectra, absorption spectra in excited state. And Braden did ask, what are our benefits of doing this oversimplified treatment of excited state? This is critically important for chemistry. If you do reactions in excited state, or if you want to describe Stokes shift, this is maybe this is replacement of Gaussian excited state optimization. If you do, if you treat excited state in a more rigorous way and decide to optimize it, it will take eternally long. With this simplification, you can get rough estimate how the geometry of a molecule responds to photoexcitation. Okay? Make sense? Mine is done. Now I will follow you, although you are already the first. Tail minus n 300 states. Yes. No, I did an error. So my results will be wrong. I cannot break. I miscounted the number of options, and now it will be highly anionic plus excited. I miscounted number of field bands, field orbitals. So I even will not plot it because it will be very misleading.
What did you put in?
I put instead of 1, 0, 3, I put 1, 2, 3. It should be 1, 0, 3 in here. I even do not want to look on it because if you do anion, like 20-fold anion, it is something crazy. Right?
Let's look.
Yeah, let's look.
Okay, by your request.
How do you execute the GNU plot script?
I'll show on this. I will do it, and you'll see.
Yeah, you just type new plot space and then the script.
What's the script?
Java/baby/new plot or new pro.
Well, I mean, you should write this stuff down.
Yeah.
You're never gonna remember.
You can't even remember it right now.
Just write it on a piece of paper.
PS2BFWR space DOS.PS underscore DOS. Yeah. 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 Literally, just hit enter.
Oh, that's it.
Is there events here?
What's up?
How do you view the
Download it to your local machine.
If you look at the directories on the left-hand side, if you go to the directory on the left-hand side.
Oh, I guess I'm on Mac, so I have to download it. But
Do you want us to do all of the states when we're holding it? Or
Huh?
do you want us to do
No, you need just plus minus the gap area plus minus 10. So I did something wrong because here is the gap and I occupied everything here. So do not follow this example. Look what Braden has. I do not know if it is possible to show.
I can. Interesting.
Can you bring up your thing on the screen?
What does yours look like?
Oh, very smooth. What did you use for like your line mode? That's the issue.
Do you, which
I use 0.1 instead of 0.01. Oh, okay. That's
that
what
works.
so nice
Yeah.
smearing.
Okay, so if you are watching the recordings or if you are watching this little window there, it is what Braden did observe. So he has occupied orbitals in valence band, and then one of the valence band orbital gets empty, right? And then in the conduction band, one of the orbital get occupied. So this red stuff was promoted from valence to conduction band. It is what you should get. I'll approach you. Thank you. Yes. Yes, you should take the watch. Yes, yes. Yes. Okay, Vijay also get it right. And Van will get it right. So you already have 3 examples.
Yeah, like the my line.
Okay. We need to go? What?
Go.
No. Okay, so I want to believe that you got the idea about excited states and what is next on our program. Multiplicity and heating. I know we are over time, yes.
Before we move on, when I'm trying to do the absorption spectrum of the excited state,
You will get transitions inside the gap, infrared frequencies.
okay, I haven't made it yet, but it's asking for the HOMO number.
It doesn't matter. Put old HOMO.
Okay.
Okay, I am going to tell something. I don't know how now I will not brag too much about value of what I'm telling, but it is so I'm erasing this stuff about pseudo-excited states. No objections? So please plan to create another directory. You can call it whatever system was, gamma, neutral. You can always keep telling that it is not excited ground, and now it will be spin enabled, spin polarized. What do you know about Isaac Asimov?
That's a good book.
Good. What is his best book? Or any book you recall name of? It's not a novel, it's a short story. Okay, I will approach from other side. Apple company, how do they name their products?
Well, it used to be based on cats, and now it's based on like stuff in Yosemite National Park.
Less specific. Like if you have a monoblock computer, when you have CPU and screen in one block, how this product is named?
Laptop.
No, it is when you carry it on. But it is if it is a desktop, huh?
Teardrop? Computer?
Okay, I'll approach from different side. How do you call the cell phones? How Apple calls their cell phones?
iPhone.
Okay. How do they call their pads?
iPad.
Okay. And the desktop is iMac.
Oh.
And the best book of Isaac Asimov is iRobot. So we are going to enable spin. Guess what would be the
spin.
Yes. iSpin equals 2. Just create new directory, copy everything there, and add the keyword iSpin into the in-car. And just run. We are not going to change multiplicity. We'll take follow whatever would be suggested. So in the in-car. Yes.
How do you interpret this absorption plot for the?
Huh?
How do you interpret the absorption plot for the excited state? You said there's going to be
2-photon experiment. First you pump system with a first photon, and then you probe with the second. But you do it not in time resolution, but in frequency domain. So you apply 2 lasers. One at tuned to HOMO-LUMA transition, keeping it excited, and then second just regular spectroscopy experiment.
So what are some features to look for then in that? Anything specifically different than ground state absorption?
You will see a lot of IR transitions even if the system has gap. If you take neutral, it will have no absorption between 0 and 2, or between 0 and 1.5. And if you take excited, it will have a lot of features in the vicinity of 0.1 eV. And there are experiments that you can match with this calculation. Yes, please do not wait. You have sharper brains and quicker fingers. Please do not hesitate to run ahead. Left, heating and molecular dynamics. if you need to go and or you're impatient or you do it like style it is instructed here as a summary.
Copied the first one to start.
Yeah. I put my ice in a little ice mirror, but it shouldn't matter. Oh. Change, add a dot after true there. Sure.
Yes, I'm sure.
What the heck?
Are you printing are you reading the PDFs?
Huh?
What?
Are you working on the Mac through that terminal?
I'm working on Windows through a GUI, but also a terminal.
How do you view the PDF, the final PDF?
I have to copy it to my local machine.
And your local machine is,
Sorry?
your local machine is,
Windows.
how do you do that? What's the command?
I can't do this in words. So, I have this program here called WinSCP. So Windows SCP, and it's like an interface. It's similar to Mova Xterm, which you're working on, right? So you're on the Windows machine, right? So you have some interface that looks like this, right? You have the external machine, and you have the local machine,
I got something similar to that
right?
too.
So I have Mova Xterm as well.
Okay, yeah, I guess
If it
what
loads.
I did, so like I did the same procedure for like calculating dead sweep state and whatnot. For my Fermi energy, I
Right,
put
so-
this number here, but yeah, the second number, yeah.
What's the? Is it USD dot? No, HPC.USD. I got it.
US HPC. USD.
Okay, so there's a lot of files in here. So
Sure. Okay.
here, okay.
So basically the minimum and the maximum you want plotted on your actual plot.
So if I click a file,
Right, yeah, I guess like,
Yeah, I can do it.
yeah, like -5 to 5 should be good.
Yeah,
Negative
so yeah.
8 to 5.
so you have both these things, right? You have your local machine and your external.
Yeah, so
So if you
-4 to 4.
if you find this directory on this side, hey, let's just go over there.
Yeah. Like the 7,
So,
yeah. That's just gonna be that number, it's the same in every column.
So
Yeah.
navigate from this side to this directory.
I can.
Yeah. And then the beach line, I do 0.005. Yeah. I mean, you can do whatever, but.
Yeah, so for the system that we're using today, it's just 29.
I can. If
This
I
is
double
the
click on it, it takes me into the
neutral
folder.
inside. Okay, so it's just going to be 280
I feel just like
electrons. And generally, you can find that by doing like grep space capital N like LCAR. Yeah. And then
Back to-
if you go back up to where you states, I think that's just the number between 104 and
Yeah,
105.
you're clicked on SFTP, right? On the left.
Yeah.
Okay. Yeah. I usually calculate out exactly, but I mean, it's, yeah, it should be.
I don't know if I know how to fix that.
So in our outcar file, when we do the spin thing, we should get like a list of all your states with the energies and occupations for your first spin, and then a separate list for your second spin.
I'll just do something to show a nice picture and do not bare words, but support. But
Okay.
you're right.
Are you sure you didn't get kicked
Yeah,
out?
that'd actually be a plus.
Did you get
because
kicked out?
0.8 is.
Can you navigate on your terminal?
I did not get it.
0.6493 plus 0.8.
Because I have the same thing happening now, but I can't.
It is what I'm doing. No.
I think just let it sit. Switch directory to your terminal.
Yeah.
That's I don't need to
Okay.
want the manuals, look at it. I know how to plug it. It's not, I'm pretty sure that works. That's what. It's,
Yes.
well, sorry man. It doesn't work.
Did you try logging out and logging back in?
Oh,
It's-
yeah, they are.
Machine thing. This.
Well, I would suggest to download.
You're probably having the same.
I don't know why it doesn't work, but when.
Well, mine didn't actually fail. It just maybe it wasn't just running it or something.
Oh, yeah, this is your phone. You can access that.
Oh, okay. So, wait.
Thanks. Yeah, I can always log in.
Yeah.
This with
Yeah.
my Linux even later. I don't know. Someone here that
So,
needs solution.
try this. Did you get like? Yeah, I just did ice. Oh, I didn't have the ice mirror in the one that I read in. The.
I have
Well,
ice mirror equals to 0, yeah. Yeah.
Yeah, so I guess you can try to zero sequences. But use that for this. I didn't have the fair.
I didn't have that either. Yeah. Yeah, I only had that for when we were doing the excited.
Oh, it's probably the Fermi way, because there's probably something about telling you like where they are,
Oh,
but then
yeah.
demanding that like they have separate screens. I don't know what exactly they're telling you best, but I think that was fair.
Probably already have in all honesty.
It's not too late.
What's up? I have no idea. It's probably just like if you're away from your computer, then like someone else can't like go in and mess with it. So it's a really low timeout.
Yeah, it's like literally a minute.
Yeah.
Oh.
Um,
Yes. Okay. Let me focus on it, and then I will go through details how to get and how to analyze. It's probably just more instructive to show end product and then analyze. So it is what you're going to get when you get a successful completion of I-spin, spin polarized VASP calculations. You, as London did ask out loud, and as you know from your tenure with Gaussian code, you will get two sets of orbitals, alpha and beta, right? VASP doesn't call them alpha and beta, they call it spin component 1 and spin component 2. But it is the same. You have two sets of orbitals. Now there is a question, how to analyze them, how to visualize them. If we, instead of alpha and beta, we call them spin up and spin down, we can make those up and those down, right? And since the energies of orbitals and their occupations can be different, we can plot them with different colors. So in this example, there is one unpaired electron, which is doublet, and the spin up has electron in the conduction band, and valence band has all electrons in the valence band. Okay? So the manuals that I have distributed guide you through procedure of making this image. I will repeat it once again just for illustration, but do not wait. If you read and understand, just go ahead and try. So when I'm looking into the out card, the closer to the end, I scroll through and observe the following. There is a list of orbitals, number, energy, and occupation. Occupation is 1 instead of 2. It labels spin component 1. And if you scroll through, further, you can observe the value of HOMO. There is no guarantee that the HOMO for spin component 1 for alpha and HOMO for spin component 2 beta will be the same. So if you write in a paper and you want to just record these numbers, you can call it HOMO alpha and HOMO beta, or HOMO up, HOMO down. The larger multiplicity, the bigger is difference between them. So here HOMO alpha is 105. And you see that there is a very big gap between 104 and 105, because this belongs to conduction, this is already to valence. Okay? And if you scroll through further, you see there will be spin component 2, and if you scroll through the spin component 2, you arrive to the region of frontier orbitals, you see that 104 is occupied, 105 is unoccupied. So number of occupied orbitals for alpha and beta can be different, right? It is for automatically it computes total number of electrons equal to 209 odd just by composition of this molecule. So you know that it is a doublet, right? A little comment that I believe you all know, but let me bring it up to your attention quickly. Just a second, before we go to practical. Yes, here. So it is shown here and on the blackboard. If you subtract number of electrons in alpha and beta components, it will be difference, spin polarization. Right? Number of electrons. If you divide it by 2, it will be maximal spin of the system. So delta n divided by 2s. And you know that multiplicity is 2s plus 1. So if this difference is 0, the maximal spin is 0, and multiplicity is 1. You call it singular. Right? If the difference will be 1, what we have here, the spin will be 1/2, and 2 times 1/2 plus 1 will equal 2. Multiplicity 2, doublet. If, by the way, you have, if in some other configurations you have 2 more in alpha than in beta, delta n2, spin 1, multiplicity 2 times 1 plus 1 equals 3, triplet. Okay? So you already are able to observe different multiplicities. And later on, there will be key word to change multiplicity of a system. N up, down equals, and then you type whatever you like, or whatever you need. Okay, I'm getting back to generating spin polarized density of states with separate images for alpha and beta. Yes?
You did all this in the anion?
No, I started from neutral. If you count...
Didn't neutral have an even?
Odd here.
Yeah, I had a question about that too. I didn't specify.
It's 208.
My neutral had 208, but then when I didn't specify analec and did this, it moved it to 209.
It should be 209. Right now, you will, when there will be time for research projects, you'll focus on your personal systems and nail it down to exact numbers. Right now, we just need to learn how to make figures. Okay? If you want to check, you look for chemical composition, whatever, 4 cesium, 9 lead, 16 iodines, and count number of electrons. And check it out whether it should be even or odd. Let me focus on the screen. Okay, so we do need to place these two lists of orbitals in two different files. One of them will be creatively named states up, another states down. Specific names are needed because next script will look for these specific names. So what I did, what I can do is to tail minus n600 because if one list of orbitals takes about 300, maybe a little more, then two lists will be twice as much. And put it into states up. And okay. Oh, it doesn't work. 600 from out car. Out car. States up, states down. Right now there will be two identical files, but I can edit and parse so that in first file I will keep the first list, in second file I will keep the second list, right? VI states up. I do deleting until I see that list of orbitals starts. Spin component 1, deleting. And then I go into the end of this list where we go to spin component 2. So I do not need spin component 2 in this file, so I delete everything after past this point. Escape, write, quit. So states up contains only spin component 1. VI states down. So I'm deleting until I see spin component 1, and after I see it, I keep deleting until I arrive to spin component 2. Deleting. And as I see spin component 2, I delete this words, and then keep numbers and go up to the end of the list. At the end of the list, I do D million times D, erase everything. Right now, I do have two files, ls-lt head. States up, states down. WC states up 144, states down 144. They take little larger orbitals than in spin in closed shell, because it is bigger challenge, and to achieve convergence one needs more orbitals. And then I practice same style of code as we did for closed shell, but I run it twice. So dress DOS up and dress DOS down. You'll see it later. So dress DOS up and dress DOS down. They are, instead of norm, up and down. And you repeat all this answering silly questions 2 times. Like Fermi energy alpha plus beta, number of orbitals in your states file. And when you're done, it will generate 2 files. The distribution of density of states for spin alpha and spin beta, for alpha and beta. If you like, you can just take these files and use them in the Excel or Origin. But we are going to use script that will merge these 2 files into one figure. So tilde binary dress DOS up, number of states 144, minimal energy minus 10, maximal 3. Fermi is slightly positive. Alpha plus beta negative. Magnitude 1, number of atoms 29, number of electrons 209, gap 2. Okay, after running dress DOS up, it generates density of states up norm. but we need the second one as well. So I'm running dress DOS down. Number of states 144. Minimum -10, maximum +3. Fermi 0.3, alpha plus beta -3.8. Width of distribution 0.1, magnitude 1, number of atoms 29, number of atoms 209. Gap. Upon a complete dress DOS down, there are two files, dress up and dress down. And after that, I want to practice the script GNU prog DOS up down. If I'm curious, I can look what is inside. GNU prog DOS. So it's not much difference to what we did before. It just takes up and down. And the values of density of states has been already multiplied by -1 in the previous script, so that they will be flapping to different hemispheres, parts of the screen. Plot. And then after this ls minus lt head. So we have DOS up down PS. So it's obsolete format. So I'm doing PS to PDF, right? DOS up down PS. Checking developed files. DOS up down PDF. And then just downloading and see what is here. Let me walk around and see that you have achieved this image. Did you?
What did you use for your alignment? Did I screw it up?
No. You just I used bigger window.
Oh, I see that.
But you can put smaller 0.005. Were you able to?
I can generate them, but then for some reason I can't view the PDF. I can put it on this machine.
You can. Let me show you. This is
okay.
six.
I haven't run for this.
But let me show it on another system.
Yeah, let me just
later.
There.
Yeah.
Those that PDF.
So we'll connect the search program.
No, you have to use dress down.
Oh, okay. So, yeah, it's repeated.
Yeah.
I'll just put them from my machine. I know it's done.
Yes, there is a signal here that gives you one signal.
Oh, I don't have to look at the PDF.
Before I go around, let me impress you by ugly thing. Some of you can find it adverse, some of you may admire it. So, what would you do if your screen, if you do not have graphical terminal? Like in 60s, 70s, and beginning of 80s, computers didn't have mouse and didn't have any graphical pictograms. There was only terminals to type in stuff. And if there were like plotters, like mechanical hand that plot something, but it was not easy to go to different room and arrange. How would you assess graphical dependence in the command line environment. Let me show something. Well, I'm not that old, but sometimes. So suppose we need to watch the file DOS up, and actually we have the whole line how to put it. So GNU what? Set term dump okay, I knew that some of you would like it.
Well, what if you don't have blue plots? Because did you have blue plot then when you didn't have
Oh, it
mouse?
is very ancient.
Yeah.
And to do pseudographic with symbols, you do not have to be a very skilled programmer. You can fill matrix with symbols and then just print file, right? See, it is what we do. So even
It's not publication quality.
well, if you do 1000 by 1000, there were pictures made of this, like mosaic.
Yeah.
One symbol, different symbols represent different styles of gray, and you do beautiful pictures. You can set term dump.
Yeah.
Yes, with different resolution, like 120 by 30. Well, our typical screens are 1000 by 1000 or above. Better resolution.
That's impressive.
Well, you can do maybe 300 by 200. Better?
Oh yeah, that. Oh, that.
It's pretty soft.
And well, actually, 300 was too humble. I can do maybe 700 by 170.
Probably more than 170. Oh, 170 was pretty.
Wow, that's nice.
Okay.
That's publication.
You told that you don't have graphical connection or whatever. You can.
No, I don't have PDF viewer.
You don't need PDF.
Never gonna use PDFs again.
I'll use PDFs.
So please show me that you can generate these figures. Well, not this, but actual colorful stuff.
I didn't even know Pixar could do that. That's really cool. At least now I know how to plot my radial distribution function.
Oh.
Next time.
Wow. Would you look at that?
No.
Wow. Too late, you already did.
Have you?
Right now we don't set like settings, we just learn.
Oh wait, you just did like plot the file.
Yeah.
Sure.
Okay, so this,
Yeah, just E space.
Yes, yes. You
It's basically this.
So you go to
GN. Who calls it GNU plot?
Losers.
Okay, let's run it.
Seriously? Oh, you didn't set. You need to do set term dump.
Oh, you do that first.
Yeah.
Okay.
Because that way it knows exactly how to output the file. Yeah, and then just do the same command.
Oh, yeah.
So that instead of doing like 3 by 5, is that where it's?
No, 3 and 5 are the columns that you want to plot. If you want to specify a resolution, then you have to set to dumb. And then pick the resolution or something. Ooh. Mm-hmm.
You like plastic?
I don't know. I've never used terminal type dumb before. Control plus. Actually.
Right. When you ran those subfunction code, what did you put in for number of electrons in simulations? For up was
I had to grab it. Well, it should be the same.
4 or 105. No, there.
I guess I put in 209, which is probably wrong for both.
Is it 209?
It's a good question for somebody that's not me.
Yeah, I put in 208 for mine.
What is 209 in the system?
Mine keeps talking about it's 208. So
Do you have your, and what, not commented on?
it is commented out.
Yeah, I have 209. In
Yeah.
When I do this, I.
Yeah.
209.
Are you sure it's 209?
Yeah.
What's your multiplicity?
uh,
Or your up down?
1.
And up down is 1. I spin is 2.
Yeah.
Yeah, I got 209 when I commented out. So, like, I had that exact setup.
Yeah. Like I've always had 208. Like it's never been 209.
Yeah, I only get 209 for this job.
I only get 208.
Well, you're wrong.
Yeah.
After the American Civil War.
It's 208 only if you specify there is 208, because plot car for this system tells you there is 209. It's in plot car. And you shouldn't be able to change that.
Right. No, yeah, mine's like literally commented out. I commented it out 3 times.
Yeah.
Like I have 3.
How do you count that?
outlines.
How do you count the numbers?
I mean, you can go through each element and count them up individually, but
How do you count that?
I just did grep space nlec space outcar.
Dan,
Yeah.
to answer your question in a sarcastic yet rigorous way,
Yeah.
you run it with the command commented out, then you add and subtract 1 and see which one has lower energy.
209.
Is it 209?
Mine is 209 when I grab and I like outcome.
Try adding
I'm
up.
very curious how you get 208.
Oh, what the heck? How is it 209?
VJ.
You get 208 because
Jeez, no.
as soon as you specify what elements you have.
Oh, yeah.
Come on, VJ.
Okay, but for my like neutral one, it was 208.
Sure.
Yeah.
No, I agree.
No, come look at it.
neutral- no,
Come
neutral.
freaking look at
I
it.
bet it was.
Dan, I got neutral to be 208.
Oh, it came out to 209.
Did it?
Yeah, both of theirs came out to 209.
For neutral.
Yeah.
Yeah, it should be 209.
Both of us got 208.
You got 208 for neutral?
Yeah.
Dan,
I'm not kidding this time. I actually checked that.
Opening card.
Okay.
Is your thing commented out?
Hold on. Just came to the directory, dude.
Oh.
Yeah, it's commented out.
And now do grab and like
and a
outcome.
lag out card.
208.
208. It's 208.
Moringa. No Moringa. Media is just.
Right there.
First one's
See, maybe when you have 3 comment symbols, it
These aren't negative signs.
well, what's oh shit?
I would ask about that. What I wonder.
Brain got 208 and it worked for him.
Your neutral was
What,
also
what, you're just grabbing Enelec from the out car, right? That's
Yeah.
just your test, right? I will go do it again.
Okay, I don't know what it should be because I don't know the chemistry of the system.
That's specified in the
Pod card. As soon as you tell
Post
what
card.
elements you have,
Yeah.
post car with an S,
That's-
POS card.
well, that tells you where the elements are.
Elements are listed there as well.
Yeah, elements are listed in post card.
So you can
But
calculate.
also, pod card gives you the potential from all the.
But you don't need the potential, right? You just need.
Well, for the calculation, you need the.
I just want to calculate the. Okay, how many electrons are in?
and then
I'm gonna do the calculation. Bromine has how many electrons? 9 plus 7?
because that's literally like
16?
the only difference in the text.
Right. Alright. I will delete 2 of these comment signs. And I will run fast.
Yeah, because mine's definitely.
What's the element number of lead? Is it 126?
I did.
Oh, you're just
I
pieced
know.
average.
Yeah.
That's like one.
Position equals 1. So 1 in good speed, just
I swear, if this is 208 and I just wasted time.
Okay, mine is 208.
Oh!
Mine's 209.
Well, you're
In
wrong.
neutral?
Yeah.
Just in the. I don't know. It's 209. No, I don't know.
I think you're wrong.
I think you're wrong.
I thought it should be 209.
Try it again.
I did. After copying his addition file, I used Concord to overwrite the postcard.
So,
So
if-
maybe a different start.
I was.
Yeah, I didn't do that.
Oh.
Were you able to?
It's just disconnected.
But the files are ready.
Oh, wait, that's right. This is the file.
I have a question.
Yes, please.
In my neutral calculation,
Uh-huh.
I have 208 electrons in my system.
Something is screwed up.
Thank you. That's what I'm saying. So, and in my spin calculation,
Huh?
I have 209 electrons.
I believe it.
It should be
Brain
209,
down,
right?
209.
Who is the biggest chemist here?
You.
No,
Brain.
I have I took chemistry last time in high school, so I'm probably the least chemist. So probably Russ.
I am the least. I claim the least chemist in here. You can't take.
So
that.
if you look through chemical composition of whatever cesium, how many cesium? Heinz?
9,
9. How many lead?
4.
How many bromines?
16.
So 16 is even. 4 leads is also even. And cesium, odd. How many electrons does cesium have? I don't care, but it has only one. All alkali has 1 unpaired electron, right? In the outer shell. So 9 times odd will be odd. So 209 seems reasonable.
That's what I'm saying. So our neutral calculation should have 209.
Yes, something is screwed up. Do not worry. You're not submitting it as a like paper.
Dan, I got 209 now.
You got 209?
Yeah.
How did you do it wrong?
I deleted 2 of my comment signs.
For real?
Yeah.
I told him to check.
For real?